Welcome to this video for higher physics. This is the next one in the expanding universe section, and we're looking at some of the evidence for the expanding universe and what is causing it to speed up or slow down. So we're going to learn that gravity is the force that slows down expansion, and that what happens to the universe is dependent on the mass, and we're going to talk about some of what that mass is, which is dark matter or dark energy, and some of the evidence of finding the mass of galaxies. Okay, since Hubble's time, we've made many breakthroughs in astronomy, and these have led us to the discovery that not only is the universe expanding, but actually the rate of expansion is increasing. And that has led us to adjust the value of Hubble's constant over the years to take into account of this. So what is causing this, and how do we try to explain it? So some of this is down to gravity. We know that gravity acts between all matter in the universe, and Newton's law of gravitation says that the force between mass is big G times m over r squared. And this gravity is what caused mass and matter to clump together to form stars, or indeed to form planets. So gravity should be an unbalanced force that is slowing the expansion down, because it's trying to get all the mass back together again. But what we're finding is that the rate of expansion of the universe is actually increasing. So this suggests that there's a force acting against the force of gravity, pushing matter apart, where we would expect it to be pushing it together. And this force is causing a significant acceleration, so it must have a greater magnitude, be greater in size than the force of gravity. So we have some big unanswered questions. At the moment, astronomers can only account for about 5% of the universe, and the rest is a complete mystery. So all the atoms and the stuff we know as matter is that small blue section, whereas the much larger sections account for things that we call dark matter or dark energy. And we're going to look a little bit more detail about both of those. So scientists put forward the idea of dark energy to account for these unexpected observations. It's called dark energy because there is no emission of electromagnetic radiation from there, so we literally cannot see it. It's said to be a mysterious field of energy which presents 70% of the universe is consisting of this dark energy. We also have dark matter. Dark matter, again, we can't see, and nobody knows what it is, but we can observe some of dark matter by how things are moving in space, in particular how spiral galaxies rotate. And this is showing that there's more material there to cause this rotation than we can presently explain by looking at the visible mass of stuff. So stars on the outer arms of these spiral galaxies should be going slower than those in the center, because they are further away from the center of mass. This is stuff that we look at in advanced higher physics in terms of rotational motion. So the stars are going too fast, and what should be happening is that they shouldn't be able to hold on to all the stars on the outside. They should kind of spin off, a bit like if you're on a turntable that is spinning round, or a playground roundabout that's spinning around. If you're on the edge, you can fly off from there. But what actually happens is that that doesn't happen, and so scientists have come up with this theory of this dark matter to explain how those stars are managed to have enough force to keep hold of them in there. Okay, there is some evidence of the existence of dark matter, and this comes in the form of gravitational lensing. So if we're looking at a galaxy that is a long way away from the Earth, perhaps 10 billion light years, then if there was nothing between us and that galaxy, we would see a direct image of that particular galaxy. But the reality is that there are things between us and the particular galaxy, and those things can bend space and time and cause the gravitational field can adjust it, and therefore we get what we call gravitational lensing. And we can see this in pictures that are taken by instruments such as the Hubble Space Telescope. So the intervening galaxy in there is acting kind of like a lens to redirect the light rays. And what we see in the pictures is we see these circles that take place from there. Okay, so you see these kind of spirally bits around the edge here, around the edge of some of the stars, these kind of streaks that are there. This is the gravitational lensing effect. So most physicists believe we are seeing the gravitational influence of fundamental particles that we have not yet discovered because they act so weakly with normal matter. So we have our universe that is expanding, and it slowly expanded initially after the Big Bang, and then its rate of expansion is increasing over time. And scientists are still trying to understand what is causing the changes to these rates of expansion. So what we've looked at here is we've looked at the gravity is the force that should be slowing down the rate of expansion of the universe, but that actually it isn't slowing it down, and therefore how do we describe what is happening there? And because the rate of expansion is increasing, we've come up with this mysterious stuff called dark energy that is causing the rate of the universe to expand. And then we have dark matter, which we need to explain why galaxies hold themselves together when they're rotating. So we've got the dark matter for the rotating galaxies to explain how there's a sufficient force to keep hold of those outer stars, and we've got dark energy to explain why the universe is expanding when really it should be contracting, or the rate of expansion should be slowing down because of the forces of gravity acting upon it.